Alright guys, welcome back to my YouTube channel and also welcome back to my project series video. In this video today, we are going to dive into a real world regression project where I predict house price using machine learning and guess what? XGBoost crushed it. So in this video, I'll walk you through a data science project where I use regression analysis, specifically SGP boost, to predict housing price with great accuracy. Alright, so let's jump in our libraries and see how we're going to solve this problem. But firstly, what is regression problem? What is regression? I think we should start from the basics before we jump into our notebook. Kind of, yes. So, regression is a supervised machine learning techniques used to predict a continuous outcome like an house price, a person's weight, and sales revenue. So regression is used to predict a continuous value like the price of an item as a target variable. And also, the key here is that regression helps us to find relationship between features like number of room or area size and a target like house price, just like our project. Our project, the target value of our project is house price. So from there, I think when I'm defining regression, I made mention of some keywords that I still need to explain properly, and that is supervised learning. This means that the models learn from a labeled dataset. The dataset we're going to be using today is a labeled dataset, meaning it's a supervised learning that we are doing. And what it means is that we have a dataset that has labeled data just like this in rows and columns. And where the supervised learning comes in is that we're going to split this data into two data sets, whereby we use one to train and also we use one to predict the result. So just stick around and watch us do this together. I know you are excited about this. I'm fucking excited too. And for this project, I use the Ames data housing data set where I have housing that contain nearly 3,000. Is it 3,000? Yes, that contain nearly 3,000. I will just go into the data set very soon, but let's just tell you what is included in my data set. It has 85 features like square footage, number of bathroom, garage area, and lots more. And now I'm going to dive into my notebook to see and also analyze this project correctly. You see, this project is a data science project in the sense that I use almost as the beginner data science library and codes to come up with this project, and it's exciting for me because I have not really done a project like this before. And because of I want to showcase this project on YouTube, and that's why I have to like be very, very, very beginner friendly. So yeah, let's jump into my notebook and let's start. So firstly, like I said before, it's an housing price with regression, a complete machine learning workflow using Ames housing dataset. So in this notebook, I'm going to be demonstrating machine learning with Python programming language to model and predict house price with regression. I'm going to make a complete machine learning workflow using this dataset from Cargo, and here is the link. So, and the goal of this research is to be able to create a model that can be able to predict or that can be able to give or predict an house price with all characteristics of house saved in rows and column given in this dataset. So yeah, it's my plan. I'm going to going through this one after the other to see that I accomplish this task. So let's jump in. All right, firstly, I'm going to import some library. Of course, you have to import library as a data science personnel. When you are working on such a thing, you have to know that you have to import your libraries, and these are my libraries that I'm going to import it for this project. So let's run that to see that our library is imported successfully. All right, boom, that's done. And let's check out the dataset on Cargo, and here it is. This is the dataset I'm going to be using, and though it has a little bit of a dictionary, but this is not what I used to see about data dictionary. It used to have its own CSV file. Well, notwithstanding, we are still going to train this data and see at the end of the day. So let's come to our notebook. Let's go back to our notebook. So yeah, I import data from Cargo. Jip, 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 jip. We are importing already. So and it's done finally. And here is our data set. Here is our data set. And here we are loading the first 5 rows and check out the values in rows and column. And all these are features variable. You can see I'm highlighting the variable I'm talking about. These are features variable and a lot of NA's value, meaning we have to look for a way to clean up these data sets for our model. But before that, we have to visualize what it takes to have this data set and also see for ourselves if at all we have any trend, pattern, or similarities between the features variable and the sales price. And here is the sales price. Always come with sometimes they might have any, but I've not seen any sales price that any of this data that comes with zero value. But it might be, it's possible, it happens. So let's check the info, our data info, to see how many non-value we have in each row. Sorry, in each column. Yep, so yeah. So we have about 85. Okay, this one is 81. Okay, 81 columns, which is very, very nice for machine learning. And whoa, some of our column we just have 13 non-value. Yeah, how are we gonna do? Okay. So let's check the shape of our data. Like I said before, we have almost 3,000 rows in our data set with 82 columns, meaning 82 feature value, feature variable, and we have 2009 130 rows in our data set. So let's check. And here is one of the column. While I was checking the info, I saw that this column has just 13 non-value, which is not good for machine learning. So let's see. Let's check in the data, the column. So here it is, and we can see I am trying to check how many value we have there, because it's not really good to have an empty row, and it's not good for our modeling already. So I'm trying to check the value that we have there, and here are the value. This is just 13 value out of 2,930 rows. So I'm going to count the unique value inside this column, and here it is. Here it is. But before then, let's visualize our data sets, because I know these things are not good for machine learning, but we'll come back there. During our data processing, we'll work on that. So, becoming one with data set, that is our visualization. I love to see my sales. First of all, I love to see the distribution, along the sales price, and see how it works. So, and here it is. This code is just practically, showing the distribution between the sales price throughout the data set. So here is the distribution plot. Here is a distribution plot, and for you to see it very well. Sorry about this. I have to make sure you are seeing this, because this is what I want you to see. Okay. So here we have the distribution of the sales price from 0 to 700,000, and we have houses that are sold around from 100 to 200,000. That's where we have the ISAs. Yes, that's where we have the ISAs. And of course, it's a little bit cheap compared to that of 700,000. So this is where we have the ISAs. Yeah, this is where we have the ISAs. So moving on from that, I'm printing out my column to see and also make comparison between them. So here I'm plotting to detect the outliers and compare distribution across area quality. You don't know, in case you don't know, these are my area quality overall quality of each housing. So here it is. I've not done plot like this before, but because of this project, I have to make research about plotting something like this. So, of course, you know that the higher the quality, the more the price is. So, this is just what this visualization is showing us. And let's check the average sales per house style. Yeah, the more the beautiful house style is, the more the price tend to be. So we see that 2.5 fin. Well, I don't really know what this fin means, but it has the highest average sales price on this. In case you are an architecture and all that, you're supposed to know what these things mean, because me, I don't know. It's all right. So let's check the relationship between the features. That let's check the correlation heat map for For each, oh, sorry, just trying to run the code for each of our data and how they correlated to our sales price. So here it is. Of course, there's a correlation between the data set. So I know we're going to, derive pattern from this data set and also predict our sales price very well. So before then, let's keep visualizing let's keep visualizing our data set and see. Here we did a subplot of four columns re- relating to the sales price. There are multiple relationship at once. So here it is. Here's the sales price like I plotted before. Then this is area. Is it grand live area? I don't know. Okay, total basement SF. Maybe total basement at the house have. Then general. No, sorry, stop garage area. So here it is. You can see that with this our plot relationship plot, we have that sales price versus GR live area strong positive correlation. Large living area equals, oh, is it? I even just say I don't even know. Okay, yeah, large living area. If a house has a large living area, definitely it's gonna have a lot of space, and a house with a lot of space costs much, and also bigger basement. If you have a bigger basement in your apartment, definitely it's gonna cost more. Then garage space adds value, yeah. Then big home often have larger basements. Yeah. Many homes have small or no garage. And you know that if you have a large garage area, you see that your price will definitely be more compared to those people that does not have large garage area. So let's see the distribution plus the probability density by overall quality as the quality of the apartment and all that. So here it is. Here it is. And also this plot too. I have to do some research and get those things done. So like seriously, as a machine learning and AI engineer, I don't often do plots. I just go get my data, preprocess, and boom, modeling already, and that's it. But today I'm going to doing all these things because it's worth doing it. So let's check the missing value heat maps. And here it is. That's what we did here. And you can see this guy has a lot of missing value fence. Like it's not all the houses that has fence. Can you imagine? Almost the whole column is having missing value. Well, we're gonna see how we'll deal with this one later, but for now, let's keep seeing that. So you can see that we have a lot of missing values, and it's not good for modeling and machine learning and all that. So we'll process our data and we'll get back to we'll see how we've done that. So let's visualize our housing data set info to see to correspond with this fence column and see how many fence value we still have as not non-value. So fence. I think it should be here. Yeah, 74. Wow, we have 74 column, not non-value, and it's an object. I want that to let you know before is that we don't train on non-value, and also we don't train on objects data value. And here the fence is an object. So we have to convert that from object to int or float. But before then, definitely with 572 value, it might be okay to, because I know that if a house has a fence, it increase the price. But we'll check all that. But just that I'm just assuming for now because I've not really done the analysis, and we'll get there. But let's do some other plot before we get there. So let's plot a sales trend over the time and see when the sales was more during this data set. So we're gonna do that. Let's run this. It's gonna do that. Gonna do that. Let's do that. Oh, okay. You can see I'm rubbing my eyes. So 2007 has the highest. Wow. 2007 has the highest. So this is the trend on how the sales price went from in years. And we have like 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 years. Like all the data in data set comprises of 9 years sales, house sales prices along the 9 years. So these are the years sold, the year they sold this, properties and all that. And all these are inside our data set. You can see there is a trend. You know, at the beginning of 2010, the price come down. Sorry, the sales come down, not the price. The sales come down. Like we don't have same amount of sales that we have in 2007. So that is what this trend is just trying to let us know. And as a data science, you have to be able to see all these things visually so that it can help you, during your. And there's one column that is very, very, very important: the neighborhood. Like if you're having a house in a very good neighborhood, definitely the price is going to cost you. So let's check and see count of house per neighbors. So we have names, Old Town, College CR, Edward, and the rest. So I believe that names has the highest count. It has the highest count, meaning we sold the highest in name. About more than 400 houses were sold in names. The neighborhood might be very, very popular. Well, we don't know, but that's what this plot is showing us. So let's do a a living area versus sales price with regression line. Let's see, maybe it really correlates or showing us what we need to know about the data. So here it is. And we can see there is a regression line drawn here in this visualization, and it's showing us that definitely this is a regression problem, and also the living area is contributing to it. Yes, yes. You can see the data was just almost in one particular trend going upward. So enough of visualization. Let's go into the data and see how we can do a features creation and extraction. So extraction. So we have to visualize our data again to see the first five row. We have to see the first five row of our data again, and here it is. So I am going to be creating some row. I like data science must know what I'm really doing here because I'm just showcasing my project, and maybe some of the time we'll have a series whereby we'll write this code from scratch and see how to solve all these things and see what it's doing. But here I'm just trying to create a total. I want to see the total bedroom in the data set. So I have to create a new row for this. And you can see I'm adding full birth, and this full birth is in our data set. For instance, I can see it here, but I know it's there. Yeah. So I just added this, and with the previous data, with the existing data, I was able to create these total bedrooms in our data set. So, and also basement, ground, and our total SF equals total basement plus first floor SF and second. So yeah, totally. I'm just trying to add some fixtures to see and to help us during our training. And also visualizing this remodel age. Remodel, yes, I added that column in the sense that I minus years sold from the year removed. What this simply means is that I'm just trying to see the year the reconstructed or the removed the house. Like for instance, if you are like having an house and want to like the number of the years in which they have remodeled the the house, like if they repair the house, like how old is the repair is and all that. So that's what I'm trying to create here. So the first one here we have 50 years, like 50 years from remodeled building. Yeah. This one is very we have short like they recently remodeled this number 4, which is good, you know. Maybe they try to make it up to standard and all that. So here it is. Still creating another one, my neighbor eats map. Neighbor targets. What did I even do here? Okay, I was just trying to create a new column, sorry. A new column. Firstly, I have to group the sales price with uh the neighbor. I supposed to even visualize. I supposed to even check to see this. Nine G map. So you see, these are the neighbor. These are neighbor per sales. So the highest sales here is it the highest? Yeah. Where is names? I thought saw names. Okay, it's not the highest, but it's one of the most popular neighborhood in this data set. But this one is the highest. We have 196,661 USD dot cent several cents, and that is the BLMTN neighborhood. This neighborhood is the highest. It come with the highest price in the neighborhood. So, and also I have to add the neighborhood target, which is yeah, one, two, and all blah 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 blah. So data processing. This is where we have to be very, 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 very observant of our data. And here I set a threshold of 95%. Like if a column does not meet my 95% threshold, I dropped the data because I don't want to, add uh I don't want to add columns. I don't want to add value to some column that does not have enough data because I don't want this to affect my modeling negatively. So instead of me to fill the NA with this that, I just dropped it because why would a label just have 13 values and you tend to correct it? Maybe you added you used the mode to add data to it and all that, but I just dropped it. So after dropping it, I have 85 columns to train. So and checking the info, you see some of our column that has 13 value are no longer there. But I don't know, maybe this is my best practice, but I just know that I did this because I don't want to fill any and also increase, and add false value to my data. So maybe it might not train and the way I expected, but this is just what I did. I don't know, maybe this is the best practice, but this is what I did in this notebook. And also, I'll be going to from here. I have to be fast because I have something doing next. I have a meeting. So I have to group by some columns and see how it's affecting the sales price. So here, defense, because I was thinking of deleting defense, but it came out strong. Yeah, so I now check how each of the unique data set is affecting our prediction. So you see that this GDPRV has the highest sales, and you see this one second and this one third. So definitely the value there has to stay. So what I did, look at what I did. If that is the case, I have to manually encode that row. So you see, since if there is no fence in the house, I have to turn it to 0. The other one, 1, 2, 3. Then I manually encode this one so that I will not have this error. So you see, our missing value is now 0. I think my model could learn from this. I think it's alright. This is what I just did. So I have to call out the column. Like I said before, if you have an object data type, it's not good for machine learning, and we have to convert the object to either float or int data type. So that is what I'm trying to do here. So I have to. These are the columns that are of object data type. All these columns are object, and I have to convert them back to int. So and here, this is where I'm transforming the data set because I want to train, and I just have to just do that ASAP. So you can see I filled the numbers value. I fill them with the mean of their column, the median. Yeah. So and also I also fill the missing value, and after that I I'm about to train. So you see, I don't want to. I might still call back to these data sets. So what I did is that I copied the data set and see the one to train with. So here is what I did. I copied the data set and you can see, and I coded it for my first training. And my baseline model, I'm using I think I am preparing data for training. This is the S and Y data, the feature value and the target variable. So Those are the S and Y. Then I split them into train and set tests before modeling. And my first module, my baseline module is linear regression, and I'm training that my data and see the results. So LR featuring mapping an error here, error. Okay. If that is the case, I just have to run some rules. Okay, so that I will know I have to run before, so you can see what I'm saying. It's just telling me that I've not run this colon and this code snippet, so that's why I'm having the error. So let's run them. Let's run them. Da, God. All right. So now let's run our code again, and it went through successfully. So let's evaluate our first module, which is our baseline module. So here it is, and we are having the R square to be 90, MAE, and this MAE is the distance between the predicted sales price and the actual sales price. So for instance, if our first column we're having the difference between my prediction and this, and I'm having like 100, is it 100? We're having 16,000 to 300.52 cents different from the the actual price. It is not bad, and look at our area score. We're having 90%, which is not bad at all. And this is our baseline. But you know what it is? Let's continue, because as a machine learning expert, you don't have to just stop there. You have to keep doing it, keep modeling till you get a very good result for your project. So yeah, I want to try my luck. If and what I did here is that, since low variance data, there's something I did here. Here I just wanted to try my luck if removing low variance data column will for better, but it didn't. Okay, yeah, I'm just trying to give you the feedback of this block code. And the truth is, I thought reducing the variance, removing low variance columns will help my prediction. So that's what I did here, and I did that, but it didn't help. So before and after, you see, the columns and everything was 271. This is after I encoded my data with a PD panda. Is it pandas dummy and all that? So I got around 271 columns to my data, and so I'm just trying to reduce the column with low variance data. So after that, look at what I got here. I got 189 columns. So I train and see my results. It reduced drastically. So I see that it doesn't help. Well. That is what we do as a machine learning engineer. We just have to try things out and see the results for ourselves. And you see this, it's even worse than our baseline prediction. It's all right. So moving on. Moving on to decision-based model like RandomForest and XGBoost, and you know that this model does not really work with it work because of it's a decision-based model. We have to reprocess our data for this training, and this is what I just did here. I just reprocessed the data, and this is where it took me a whole day to see that I processed this data. It was, time consuming and all that. So I have to all this one. I'm just trying to visualize my data and see for myself what's happening, and all that. So yeah, it is. I was visualizing. I was trying. Sorry for doing all this. This code block took me almost a day. I'm not. Honestly, I have not. This is called manually encoding. I haven't done something like this before, but doing it today or doing it yesterday. Yeah, I did it yesterday. Doing it yesterday was something big that I was like, so I usually used to just, do my encode automatically. But this project, I want to do this to see if it will definitely affect the predictions or not. So I have to manually encode my data with ordinary. I was mapping each of the data to value. Like for instance, these are the categorical columns, and look at the way I'm mapping the each data, each values in the columns to one zeros and all that. So I finished doing that. This is the work of machine learning, so this is it's not a big deal, but just that it took my time and all that. So after doing that, all that, I just want to finish this recording very quick as possible, so I can do other things today because I have other things scheduled for today. So boom, I first after doing all that, after doing splitting, I and one thing I did also was to scale this data using the standard scaler. So this is where I train and I fit the data into standard scaler and all that. I have to transform the train data set, but I didn't transform the test data. And this is I don't want it to start learning part, because if I should do something like this, it will prompt to overfitting and underfitting while predicting on a neutral data set. And that's I don't like that. So I transformed the S train and fit them, but I didn't fit the S test. And that's our testing data. Like I said, it's supervised learning. We have to have two data, a train and a test data, for us to test our prediction if we are really doing the job properly. So here are my two data set I want to model with the S train, and also test with the test S test scale data. And here is their data frame. But I will not print that out. Okay. We're having the same error that we have to run our previous notebooks. Okay. Running our previous notebook, and you see, but before then, let's check out our previous. Okay, it will not show, it will not show. Okay, let's wait till it's finished running and all that. Before now, I told you this is a good beginner friendly data science pipeline. Okay. So let's run now. Let's run now. And see our data set in training. Whoa! We can see the previous one. We have 90. Is it 90? 90, yeah. 90 R square results. Yes. And we have 16 plus something as to be our MAE. Is it 16? Yeah, 16. Yeah, 16,000, something like that. But now we're having 15,000, which means this has reduced between our predicted price and our actual price. Wow. This random forest performance was good. It's better than the first one. So let's just go using our XGBoost, because they are both decision based model. So let's run that. 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 Yes, yes. Wow. It's still reduced. It's reduced. Okay, look at our Jaime. Just something I'm not going to do. I'm not going to cross validate or even try to see if I can use my great search CV to reduce all this. But maybe in the next project, maybe I will do that. But for this project, I don't think I have that as a scope in this project. So we are going to stick with these predictions. This 94. This is our highest accuracy. for this project, and this is the threshold that we are setting for ourselves, and this is okay like this, so we are not going to do any further analysis for this. But just like let's compare the visualization of our project. Let's compare the actual and the predicted results. So using the SGB predicted value, we are going to check the actual and the predicted value. So here is this thing. Here is the map. Here is the graph. We can see here we just lost to some and we won many, sorry, we won many, sorry. So you can see how it predicted. The red is the actual value, while is it the black is the actual value, while the red is the predicted value. And you can see here we see a lot of red compared to that of other ones. So we're going to compare this one to this is a SGP model in training in action, and this is what it does. It almost align with the original prediction, meaning the actual prediction. But it's nice. It's nice. The actual price, sorry. And like I said, the red is the predicted, while the black is the actual. So let's check out the random forest. Here is the random forest. Yeah, it tried, but we still have a lot of black. Yeah. According to the result, we have 93 for this. Then why we have 94 for this. So let's just check the linear regression analysis too. It did well, but not up to. So here is the linear first, and also there is something that this is for the stakeholder, the company or the real estate firm that is trying to predict the price of all this. We want to see the fixture that affect this prediction mostly, and the first one is overall quality. Definitely, the overall quality will definitely affect the prediction, because the overall quality is just like how good and how bad is the house that is the house in dataset. And here it is. It has the most is the most influential column for these predictions, and it's fine. It's justifiable. Then the total SF, yeah, the neighbor target. Like most of this, I don't really know most of these column, but I know that these are the feature variable that affected the prediction mostly. Here is the kitchen quality, land contour, removal, remodel age, yeah. Then overall condition, yeah, overall condition. The first FAR, roof material. Oh God, I'm knowing these things. It's like I'm very familiar. I'm getting familiar with the data set and its science, because the first time I loaded it, I was like, "What the heck is this?" So the central air, total bedroom, and basement quality. Yeah, basement quality and all that. So here are my objective. My primary goal was that of this strategy was to build a robust regression model to accurately predict houses price using various property feature, and the outcome aim to support real and the outcome is to able to support real estate investor, developer, and analysis in price estimation and informed decision making. So you see, with this model, an estate developer or estate investors or analyst can look at this prediction and also use it to make an informed price decision. So, like I said, these are my data overview and explorative. Like I said before, the linear regression did well, but not to that of random forest. Random forest did well, but also the XGBoost outsmart or outscored the rest, which is very nice for our prediction. And that is what this is where we're going to stop. And also the future importance, we can see the columns that that influence the prediction. So yeah, we see all our prediction and our modeling, and I must say it's a nice project. Like I said in the beginning, it's a data science pipeline, and I've not done something like this before. But today I have to do this for the project. I have to do it for the grants. So, and also there is okay, yeah, yeah. I've already explained that one. I've already explained that one. I've not already explained that one. Don't forget this my project series video, and if you found this video very helpful, drop a like, subscribe, and let me know in the comments section what project should I do next, and what are you even doing as a data scientist or machine learning engineer. You can share in my comment section so that we'll know what to work on and also know how to help each other out. Because don't forget, it's a beginners learning friendly, so you can just jump in. And if there's any place you'd like me to emphasize on, and also if you want this full notebook or visual or code, check in the description below. Thanks for watching and keep building awesome projects. Catch you in the next one. Goodbye.